Hi, this is Adnan Shahriar, and welcome to a resilient extraterrestrial habitat. Occasionally, meteoroids impact the habitat and cause damage. When this event occurs, excitation can be read by a real-time internal communication network, which sends signal to a robotic agent that will perform repair operation. An structural mechanical model, in short SMM, is a numerical model that replicates the damage and excitation of such physical habitat. SMM is an integral part of MCVT or modular coupled virtual testbed, where it is highly interconnected with other models. The SMM takes external loading, such as temperature, internal pressure, acceleration, and impact force. It also reads and responds to a damage variable received from the robot or human model. The SMM passes the current state of damage variable to the structural, thermal, and interior environment models, so these models can be account for the damage condition of the habitat within their calculation. It also provides the acceleration response to the FDD. The output and input ports can be extended as required for this model. The SMM was developed with three functional requirements in mind. First, the model must approximate the behavior of the habitat through physics-based equation. Second, it must have damageable and repairable features. And finally, it should be executed in real time. The finite element method and numeric beta time integration scheme were used to solve the 3D structural dynamics equation. In the image on the right, the displacement field of a pressurized dome was obtained using this developed model. Damage had been associated with volume loss at Gauss point, VL. This basically softened the stiffness matrix, where the updated stiffness is smaller than the previous stiffness due to damage. This segment is also known as damage variable D. Repair has two aspects. First, it restores the stiffness, so D gradually goes to 0. Second, repair process does not cause any excitation, hence the acceleration due to repair is 0. The real-time model is a 138 degree of freedom model with around 3000 Hz of sampling frequency. This model consists of a 9-node novel element with a center node at the surface of the element where the impact occurs and 27 Gauss points. To achieve real-time capability, model order reduction is done that leaves 90 degree of freedom. And then domain decomposition is done that isolates a 27 by 27 matrix where damage and update of the stiffness matrix would be carried out. An efficient algorithm for real-time has been developed. In total, around 0.7 million floating point operations has been reduced, which expedite the codes significantly. And finally, welcome back to a resilient extraterrestrial habitat model within the MCVT. The dome in the left-hand side is subjected to external loading, such as thermal stress, internal pressure, and white noise. The effect of these forces can be reflected by the acceleration norm. An impact event happened at 10 seconds, causing a stiffness drop and a huge spike in acceleration. The habitat is in unsafe state now. This triggered the FDD, and the FDD triggers the robotic agents. Robotic agents initiate repair at 25 seconds, gradually restoring the stiffness without causing any excitation. And finally, we end up having a safe and resilient habitat. Thanks for watching.